Un, dos, tres. Bueno,
Good morning, everyone. Welcome to Roundtable C, Investing in Fusion Technologies and Skills. This is the first time that we'll be actually talking about the competencies that we need in the fusion landscape, the people that can make this landscape a reality, and then we will also take a deep dive into the different technologies and their maturity. The delivery of fusion energy is a multi-generational endeavor. In this session, we will discuss the skills to be promoted and the ways for FRE to engage with younger generations to join this field. In addition, we will highlight the key fusion technologies that Europe needs to develop to be in the lead. Some of the questions that will be addressed are, what talent and skills for the future workforce do we need? What are the critical technologies we need to develop? We will start with a keynote address by Cehila González de Vicente, Global Director for Fusion Energy Section, Clean Air Task Force. Cehila, the floor is yours. Thank you.
Thank you very much. And first of all, I would like to thank the organizers to invite me to give this keynote that will be followed by an excellent discussion by my colleagues. So, we'll try to address these two important topics, gap in technologies and skills and workforce. First, we will go through the technologies and then about the workforce. There's two important topics that are correlated each other. So we cannot progress without good facilities, and we cannot progress without good people in fusion. I have to say that yesterday we have really enlightening conversations, and many of the topics that I'm going to highlight in this introduction were mentioned already. So it will be sort of a summary and wrap up. The first thing that I want to highlight is in Europe, we already have a number of machines, the fusion machine and fusion system. So we have a tradition, we have this knowledge, we have this technology development. Not enough to push toward commercialization, but we have a very solid background. We have as tokamaks and spherical tokamaks. I have listed ASDEC, Compass, Smart now in Spain, previously JET operating, GT60 SA, to be built, the DTT, and all the EU demo program. We have accelerators. We are the strongest country, and I assume Europe is as a single unit in the world pushing for accelerator. We have Weatherstein 7X, which is the reference. We have a smaller one in Spain, exactly not accelerator, but in the family, TG2. And then we have big projects to build new machines. Proxima Fusion is building Stellaris, Renaissance Fusion, Gauss, and we have recently also some projects on inertial fusion. So as you can see, in Europe, we have a really good basis to progress, not only in technology, but also in plasma expertise. What is the problem here? And this is transversal to all technologies for all systems in the machine. The TRL, the technological readiness level, we are too low. We are in the research step. We go from 1 to 4. That means that many of the components, many of the materials has not been tested in real environment. To go towards commercialization, we need to go beyond. We need to test components and systems in real fusion environment. And that will allow us to go from TRL 3, 4 to TRL 8, 9, what is needed for real commercialization. And I think all the conversation of the technology gaps, how can we go faster, how can we push toward commercialization is around this metric. How far can we go with the TRL, with the existing machines, and which are the next testing devices that we need to build or refurbish to increase that TRL? So whenever we ask ourselves, do we need this device? How can we go further? Try to refer to a TRL. How can I increase this number? How can I move from 4 to 6, from 4 to 7? How can I go in this scale up to operation, which is at the end commercial machine? So we have a number of gaps. They were both discussed more in depth in the presentation, but clearly, and I think this is understood by everyone and not only by me because my background is materials, we have to advance in materials development, and they are suffering because this reduce or lower TRL. We need to test materials in real environment. We need to test it under diffusion neutrons. We have to test it under the loads, thermal and mechanical loads together with radiation. So there are a number of experiments of data that we need to know. And this is related to the lack of irradiation facilities specific for fusion. And I will say sometimes the shortage of pre-irradiation testing, so radiation that is not done in fusion environment, but help us to tailor the perfect or the most optimum matrix for testing materials in real environment where the volume is reduced. So I'm talking about irradiation campaigns in other devices like fission power plants, where we can get data that will help us to understand some of the phenomena and to optimize this final matrix to be done in facilities like IFMIF-DONES that I will show you a little bit later. We need to understand the tritium breeding and the fuel cycle. Breeding blankets are the key. A fusion machine will not work. The whole fusion concept machine will not work if the tritium is not bred properly from the blankets, and the blankets are working as expected, able to extract the heat, able to handle the radiation, able to protect the rest of the machine. So these key elements that has not been tested so far. Remote maintenance technique. All the fusion machine has to be handled remotely. We need to go further in that. We need to understand which are the technologies that we need to make that thing possible. The plasma exhaust. This is a key issue. How we are going to source the plasma, how are we going to, the configuration that we need to have in the machine, the materials that we are going to have in the machine to be able to have this plasma exhaust. This digital twins and artificial intelligence integration. This is something which are relatively new tools. Someone will tell me not so new, but they are relatively new, and they need to be integrated into what we do in fusion. And I will give a little bit more of data related to that into the next slide of things that we need to do. The first, coming back to what we have and how we need to move, I don't like to say we have nothing and we are lacking information, lacking people. We have a lot of things. And this is what makes Europe to be in a really good position in this race to fusion. We have a great background, probably the best background that you can find worldwide. We are 40% of the contribution to ITER, with all the implication that does have, all the lessons learned, all the technologies that have been developed in Europe, all the experts that have been generating in Europe, and the development of the supply chains that we have mentioned yesterday extensively. This is a unique opportunity. We need to be able to integrate it in our program and take advantage of that. This is the real challenge here. We have also GT60, where Fusion for Energy is contributing to both. That was a successful story. GT60 is the largest tokamak operating today in the world. It has been built within a collaboration in the border approach, a number of technologies, and now during operation, we are going to have access and to be part of this huge experiment where a lot of lessons learned has been go through. And we need to take advantage of that. We need to leverage these two big projects. So far, as I said before, ITER is the biggest machine in construction in the world. GT60 is the largest tokamak in operation in the world. Both are European or European contribution projects. We need to take advantage of that. We have a long tradition in EU demo design studies. We have this also as a part of collaboration of the border approach, but also as part of big part of the work done in Eurofusion. Probably this is the best machine, the best characterized machine in the world in terms of fusion. At the end of the day, when you see a neutronic calculation or any simulation, everyone uses the EU demo design. Why? Because it's the more advanced. We have more knowledge about how a next step machine should look like, or problems that they can face, or things that can be improved than the rest of the world. Let's take advantage of that and build on that. We have IFMIF-DONES that is being constructed in Spain, in Granada, also with the contribution of F4E, and that represents the way to go higher in this TRL, to be able to have a unique facility also in the world which mimic as much as possible the fusion environment. That will give us a really competitive advantage. And there are plans and discussion, this is under consideration, of a volumetric neutron source. Both machines are complementary. In the volumetric neutron source, you are able to test big components. You have more volume and see how they operate. That will put us in a unique position to be able to test, again, to go to 8 or 9 TRR, to test components and materials in the right, in the right environment. So we have many things. Are we taking advantage of all of them? In my view, no, but this is something to be discussed. Do we need to still do a number of things? Yes, we have a number of gaps, and I have mentioned before. But with all this put it together, the biggest challenge in fusion is integration. We have pieces and components, but we need to be able to integrate it, and we need to be able to build a machine where we're integrating all these components and make it work. Understand what is going on. Well, understand the synergetic effects, understand that the whole technology is working together to produce, at the end of the day, net electricity. That is what we want. So that is a real challenge of fusion towards commercialization. Integrate all systems, all components, and make it work. I want to be a little bit critic here. So we have a number of innovations out of fusion that are providing us a number of new tools that can make us to go faster. That it means that going to give us all the solution? No, but it means that we can take advantage of that. So we have all the breakthroughs of fusion experiments, and we have to analyze and we have to understand as much as possible for all this data. I think this is something that we are doing, the fusion community. Are we taking advantage of the new materials enabled to build smaller and cheaper machines, high-temperature superconductors, and other materials? Are we using additive manufacturing as much as possible? Are we pushing into that line to be able to build our Eurofer pieces, our tungsten pieces, by using this technology? Are we taking advantage of all this computing advancement or the artificial intelligence tools to make better designs, to push for this integration, to understand better the synergies within the machine? And I don't say, as some people pretend to believe, that all in silico designs will solve everything. No, but it will help a lot. And this is what we want, to short the way, to short the time. Are we using this advanced manufacturing? Also, from the point of view of business model, are we using all the knowledge, all the new tools in this business model improvement? Are we able to attract the private capital to get into our projects? That because capital makes you to go faster. This is something that we need to keep in mind. We want to go faster because we want to deliver electricity into the net. So the challenge is, are we integrating all this? Are these integrating in our work programs? And I want to highlight that thing because I think partially not. And we need to take advantage of all potential tools that we have available. And now moving to the talent skills for the fusion workforce, and linking to what I have mentioned. When you go to these new technologies, we need new profiles. We need people who are expert on artificial intelligence. And we have them in fusion, and we have already here at FORE, but maybe we need to make an effort on that. We need scientists, we need engineers, but as long as fusion is progressing, we will need to include new profiles. We'll have to attract people from marketing, we'll have to attract people from business, we will have to attract people from lawyers. So that represents an opportunity to open fusion to the rest of the society. And somehow, as we were discussing yesterday, to have this society acceptance of fusion because it's more popular, not only for a niche of scientists, physicists, engineers. We will need operators. So as long as the technology is progressing towards commercialization and then to have a fusion fleet, hopefully soon, we will need these profiles to enlarge the fusion community. It's something that it will not happen one day by other. It's something that we need to start to think about now and to create the basement, the foundations to build that. Our colleagues will talk more about that. So, and here I want to highlight the importance of facilities for training. People need to be trained. People need to learn. I have mentioned a number of facilities that we already have. We need to make the full use of them. And for the new ones, you need to accompany everything with a training program. Technology hubs provide a platform for coordination and collaboration and opportunities for training. We cannot forget these elements when we plan what we are going to do with a facility or what the budget that we include or whatever other aspect. That should be part of the conversation. And with that, I will thank you and I will pass to Asun, please.
Thank you, Sahila. So if we were to capture some of the keywords that you said, you talked a lot about integration, you talked about skills and training, the potential of using all these facilities, but also the ambition that the fusion landscape should demonstrate to open up and embrace other specialties that we should bring in the landscape. Without further ado then, let me move to the panel moderator, Asun Fernandez Carretero, Head of Industrial Strategy, Skills and Technology Transfer, from the Director General of the Joint Research Center of the European Commission. She'll be moderating the panel that will bring a group of distinguished speakers from different disciplines and areas to debate further on that subject. Asun, the floor is yours.
Thank you very much. Thank you very much, Hila. Very nice. We have been going through the main challenge that we were discussing during these things. I wanted to introduce our panelists that will join Hila to have this discussion. So first, I welcome Gianfranco Federici. Please join us. He's a program manager at Eurofusion, currently on assignment from Fusion for Energy. He brings more than 35 years of experience. Most of you will know him. For me, it has been the first time, so it's very interesting to discussing with him. He has experience in fusion reactor design, development of fusion-enabling technologies. Currently, he oversees the top-level planning and coordination of the Eurofusion Consortium work plan, which involves more than 30 laboratories and about 160 affiliated entities. So a very nice overview of the situation. I will continue with Professor Guido van Os. Please, Guido, will you join us? He's an emeritus professor at Ghent University and founder of key European fusion education programs, such as the Erasmus Mundus, European Master in Nuclear Fusion and Engineering Physics, and International Doctoral College in Fusion Science and Engineering. Guido's research in controlled magnetic fusion spans multiple European institutions and includes over 650 publications. Let me continue with Dario Cruz, please. Chief Executive Officer of FuseNet, the European Fusion Education Network. His background, both in physics and energy engineering, combined with his experience both as researchers and education, position him uniquely to support mobility of students and create programs for how they will develop and how we will integrate research infrastructure, colleagues, and academia. Luca Bocciura, please join us to the panel. Leader of the R&D program of the Muon Collider. Luca's expertise lies in the design, testing, and manufacturing of superconducting cables and managed critical for the fusion and particle accelerations. His innovative work has been crucial and essential for contributing to large projects like ITER and LHC. And last but not least, please join to us Benoît Forestier. Acting Head of Unit for ITER at DG ENER, the European Commission. He oversees Euratom legals and financial obligations for ITER, supervises project progress, and ensure alignment between European institutions and ITER international governance. He plays a crucial role in shaping the European fusion strategy, which it was yesterday mentioned many times, so we will take advantage of you being here, and industrial innovation and regulatory frameworks that support fusion as a decarbonized energy source. So thank you for being with us. We will take advantage of your pressure, your insights, and your knowledge. Thank you also, colleagues, for being with us. We know that today you have to take a decision in which panel you will be, so we'll really appreciate it being with us. We have a lot of things to tell you and to share, and you will not regret being with us. So I will really ask you to be attentive and to even following the introduction, make provocative questions with them. They are ready for that, and they expect that from you. So please, I will invite you for this. One advantage to be on the second day of an event is that most of the things has been said on the first. So what I was preparing here does not need to do it, and we could jump quickly. So no need to say fusion is important, fusion is needed, fusion it has been the promising things, but now I think the message that we will get is fusion is here, and we need to react, and we need to move. Yesterday, some of the colleagues were mentioning and quoting Draghi, Letta, as an accelerator. I will go to a third one. I would like to take ITER as a reference, and I will go for the AAA. Fusion now should follow ITER. Align, add, and accelerate. I think it's the moment to accelerate. So put resources, and let's go together. So CEGILA has been growing out through the situation, the state-of-the-art infrastructure you have been doing many things, so congratulations. Now is the moment to take the position, look what we have, and have a bit of foresight. What do we need to move quickly and to react? Integration, reaction. I think it's very much important that we will put things together. And this is what I'm going to do as my colleagues. I will stop because I have become passionate for this work, but I will pass the first question. I would like to compliment on CEGILA. Gianfranco, on your extensive experience in fusion reactor design and development, in your vision, which are the main technology gaps beyond ITER that need to be addressed in the short term, in order to achieve a credible and attractive plan for delivering fusion power?
First of all, I wanted to ensure that the presentation of CEGILA was very comprehensive. Everything was in there. I think we need to try to avoid the tendency. There is a proselytism towards technology, which is very good. Everybody wants to work on technology. Everybody wants to develop additive manufacturing or HTS, more performing magnet. I think we have to separate between what is really a showstopper, something that if we don't find a solution quickly, we don't go anywhere. And I think we have done a good exercise in the last 15 years to isolate those problems which really require an emergency strategy. And there is a consensus that I feel is developing. And the problems have been mentioned yesterday, they've been mentioned today. And they are all circling around the inner core components of a tokamak. The diverter, ITER is there to provide the information required to confirm the performance and the reliability. I think Fusion for Energy has, as part of their procurement, developed very state-of-the-art technology. And the problem with the diverter was trivial compared with the product blanket, is to withstand a very high heat flux. It's a basic tile mounted on a pipe. And in the pipe, there is a swirl tube. So there is an interface. Now, if you look, the other problem is the breathing blanket. The breathing blanket is mentioned many times. And it looks like everybody understands that if you want to go to the moon with a rocket, and it can be a tokamak rocket, or a stellarator tokamak, or a stellarator rocket, or a spherotokamak rocket, or an inertia confirming rocket. If you don't have a breathing blanket, you don't go anywhere. So I think, to me, this is becoming the real problem, the showstopper. And we have been spending some time discussing, debating, and now we are trying, and we were hoping that ITER would have address this problem. We knew that it was not going to be sufficient because the TBM program has been on the inch to be canceled many times because it's something which is a complication. But we need to have the validation from some nuclear device. And now we are boiling down to find the best way to qualify the breeding blanket. Because, as correctly Seila says, we are in the domain of the labs research, TRL 1 to 4. Now to bring this up to 8, it's a hell of a job. Honest, the TBM was meant to address the 5 to 6, because if you look at the TRL, remember that the TRL are not the right metrics for fusion, because the TRL has been developed primarily for modular system. There is an SRL, a system, because if you develop a TRL of 9, and you got at the end the technology cannot be integrated, you don't go anywhere. So DONES is there to bring this above, and I think Seila correctly said that, but what we do above is not clear. And it's a contentious item, because it's not an easy solution. It requires investing money in a nuclear infrastructure to be built somewhere, to be operated. And this is still in discussion. So I think we know the problem, and Seila said it, because yesterday I had the impression we were accused as a scientific community not to have really done the job to identify the problem, to solve the problem. The breeding blanket is there as a problem, it's been there for many years, and the surrounding treats a fuel cycle. There are many other things, but these are showstoppers. So if we don't come up with a solution, and I think we have to rely on the support of the private investor, because otherwise they don't go to the moon, we don't go anywhere. That's my opinion, and I think that opinion has been voiced in many occasions.
Thank you. I would like to continue on the TRLs that you had been mentioned. Maybe I will go to, just a moment, on the TRL, which it has been mentioned by both of you as something like this. It's good to have a reference. It's good that also we need to understand also that we will need money. And the European money is usually go for high TRLs. We are not really for risk. So the existing technologies facilities to be utilized to increase the TRL are enough? What else will we need? What other type of infrastructure we will need to advance readiness on the beyond IT requirements? And DONES will be enough.
Well, obviously they are not enough, otherwise we would have gone further. There are a number of facilities in Europe that have provided us the knowledge that we have, the testing that have been mostly for ITER, but not enough to go beyond this TRL 3-4, depending on the component, on the system to be tested. We need new facilities, or eventually an upgrade of existing ones. We want to go to this fusion environment where you have 14 MeV neutrons, where you have the right loads, where you have the whole combined, and this is not existing so far. One of the machines that will help us to go higher in TRL is IFMIF DONES, as we have mentioned, to test, and Gianfranco correctly say, this is not enough, it's something that will help. We need complements to that. I'm very supportive of a volumetric neutron source too, and I want to make very clear, it's not one replacing the other, you need the two if you want to go higher, really, in the TRL. To understand the fuel cycle, we want to go deeper into that. We need to handle large amounts of tritium, and we need to be able to understand how to handle that. So there are a number of showstoppers that unless you have these facilities, you are unable to go further, and of course you will never reach to integration. So this needs to be addressed. Said that, I would like to add something here. To be able to have a meaningful roadmap to include those facilities that will make us to go higher in the TRL, we know and we have addressed what we need, but we need also to hear from the private sector what they are interested in, what are their needs. Probably they are matching our needs because the needs are there, but we need to include them in that discussion. And we need to move forward, and we need support from everywhere, from the private and from the public, to move towards. Gianfranco, please.
Would you like?
I think we should not forget ITER. ITER has been, it is, an important reference point. We have high level of readiness in some of the systems thanks to massive investments which have been done in ITER in the last 30 years. And what we have learned from these investments is these are decade-long efforts. It's something that you cannot solve in one day. So the word acceleration, I think we have a clash here that, of course, we can do things better, we can do things quicker, but we are confronted with technological problems which are not easy to solve, okay? So ITER has brought the technology readiness of a number of systems up. And we should recognize this. Now, we have a number of systems that ITER has not really considered. And I go back to the showstopper. Now, the magnets, in my view, and I might disagree with Luca, who is actually convinced, and I believe he's right, that we need to invest also in this system. So I'm not ignoring the need that we have to invest in other things, okay? I think we need to address the showstopper, but having said, we should not be oblivious of other opportunity, and now is to invest in that. But we should not really look at the ring under the lamp, because there is no ring under the lamp. Because it would have been a ring under the lamp. You know the story of the ring. What are you looking at? It's the ring. Have you lost it there? No, it's the only place where I can see it. So I think we need to go in area where we do not have much. And the fact that there is not much is because these are the tough problems that fusion has been confronted with for the last 40 years. Okay? Now, TRL is important. ITER is there. Seila is of the opinion, and I think she's right, to build up a systematic database and to try to start, and I think we have to do this with industry, because and coming from a research environment, I really feel the weakness of this approach, and I've been discussing this with the Director of Fusion for Energy and the Director of ITER organization, try to find complements, because we have developed solutions from the point of view of a researcher. So we find solutions which are overcomplicated, very expensive, supply chain of the material is not guaranteed, reliability is not looked at, fabricability is not looked. So I need to go from 4 up, we need by far to have industry in the loop. And this is not easy. So I think the TRL is a ladder, and it's a ladder where the steps are not equidistant. The higher you go, the distance between the 2 steps become larger. It's there where we need industry, and it's now. And the competence of organization, where this strength, and certainly in the area of under supply, Fusion for Energy has a lot to say.
Thank you, thank you. Thank you both. I think it's important. It has been mentioned many times, integration, how to put pieces together, how to make the best use of everything. So it's key infrastructures. Where to test it, where to develop, what to things. You had mentioned Luca, so I will address to Luca the importance of operating research infrastructures, how they are put at the service of this increase of the TRL. So I would like to ask you, which are the lessons learned that you are having on putting your infrastructures at the service of this improvement.
Thanks, Susan. Thanks for the opportunity to come here. In fact, if you don't mind, I will spend just 2 minutes on a reflection on asking myself, why am I here, by the way? So I guess it's to bring you the example of CERN. I'm at CERN since now more than 30 years. Spent 10 years in fusion, by the way, so, which was a very nice experience. And I'm glad to be back to tell you an example, a way that we learned at CERN. The European Center for Nuclear Research, we bear the name Nuclear, we are proud of it since 1953. And we have 4 pillars for our mission. One is excellent science, collaboration, but then technology and innovation, and education. So I think it's very appropriate to this session, right? How do you invest in technology innovation? How do you invest into education? I guess that's why I'm here. So, and in fact, to reply to you, indeed, we have unique research infrastructures, accelerators, not only experiments, testing, cryogenics, magnet construction, computing, controls. It's actually a very complex system, integrated, a bit like a tokamak would be, or a stellarator would be, a fusion machine would be. And what we found is that you can do development, but the best way that you profit from development is direct that to the infrastructure, to an object that is a perennial result of the development. That's what puts a flagpole, a direction for the development, and makes the things align towards a very efficient development way. At the same time, the infrastructure also is very useful, as Saida mentioned, because you train generations of scientists. You know, typically we have 1,000 students coming out of CERN and something like 750 fellows, postdocs. And that's how they get good, you know, having their experience on the infrastructure, whatever the infrastructure is. So I think if I can bring a message here is that it's important the focus of an engineering realization. That's where industry gets into it. And that's where you get the system readiness level up.
Thank you very much. Maybe I will address to Guido. You have also an experience to share with us on put research at the service of development of new fields.
Of course, the experience from CERN is very valuable, but I would like to stress also the importance of what Sheila showed in her last slide, the importance of new facilities for training, but not only for training, because hubs like this for the training are also hubs for platforms for coordination and for collaboration. So this is very important, not only that there is good teaching, supervision and so on, but that there are training facilities. So this was already mentioned yesterday also, I think, by Jérôme Bucalossi, the importance of new facilities, because now there is some training on existing devices, tokamaks, stellarators, and so on, but we will need new facilities for technology hubs on the one hand, what Gianfranco always stresses, but also for irradiation facilities, where materials, for instance, or components, diagnostics, can be irradiated with neutrons. And this is not so evident, because for this you cannot locate it at the university. It has to be in a nuclear research center. And maybe to make it more concrete, an example would be the collaboration, for instance, between Belgium and Jülich, which exists since more than 40 years, excuse me, and also with the Netherlands. This could now be in a different field, because in endeavour we have Magnum PSI. In Jülich we will very soon have the Joule PSI linear device in hot cells. And in the Belgian Nuclear Research Center, we are now building an irradiation facility called Minerva. And by the way, this is an example of synergy between fission and fusion, because MIRA is in the first place for fission, transmutation of high radioactive waste, radioisotopes and so on. But the first phase, which is called Minerva, will have 100 MeV proton beam, which is also useful for irradiation of materials. And with a spallation source, we can have neutrons in a range 17 to 20 MeV, so a fast spectrum. So this can be useful, for instance, for DONES, for VNS, as preparatory tests, but in the first place also for education and training. We are now establishing a fusion user facility around Minerva, and hopefully in collaboration with the partners from Jülich and from endeavour. So this could be very useful. And I think it is also essential. We need a new type of training facility for young people, for the new generation, and hopefully in the framework of the public-private hubs. But on the other hand, facilities like this, which require a long time of development, a lot of investment, and without guarantee of success, I think this is much more something for governments to take care of than for companies.
Thank you very much, both of you. Yeah, in this, I think this is a part of that we will discuss on the governance. How to put together pieces is extremely important to have on these infrastructures, and we are building, we try to work always by silos. We think the infrastructure for the nuclear, the infrastructures, but it has been addressed by Cecilia and also by Gianfranco. Integration to identify synergies. Your examples are both great in the sense that Mira started for fusion. So I would like to address, Gianfranco, to you. How do you think that we could integrate with other emerging technologies that it will be suitable for fusion? How we could take advantage of these developments? And how even they will know that they are on demand? Because one of the things sometimes is that they don't know even that they are needed, or they could have other uses. Yesterday we saw in the panel, some of the colleagues say, well, I cannot focus only on fusion. If I wanted to make my company profitable, I need to move another way. So how we could also do it in the other way around to attract people? How we can do it in the other way around to attract them, to say, where your work on advanced materials, it could be also of interest for us.
I have to be careful because I'm sitting beside Benoit, and I think he knows. I think, in my opinion, we have been taken by surprise, and it's a good surprise. This attention towards fusion, it was unexpected. And to me, independent of the credibility of the plan, they are fresh air. Fusion cannot be, in my view, implemented in the near term. But we need to develop a plan. And they are claiming, and they're right, we don't have a clear plan. We have a plan for ITER, which is okay. I think it's a plan which we all know. It's a difficult project. But now the question is what else? Because I think we need to take into account the fact that ITER is getting there, taking a bit more time, but we need to develop a plan, and it's not easy to develop a plan, okay? Now, once we have a plan, and creating a plan is not easy, because there are too many actors in Europe, from my point of view, and there's always a tendency to do a bottom-up plan, and then start the constraints. We need to find a way to implement the plan, so that come to the governance. The problem is that, and I believe firmly that the private must have a role in this. But first the plan and the role. Now, you know, since they have come, I've been trying to talk. It's very difficult. Here is a clash of culture. And it's difficult because there is intellectual property knowledge there, and they're trying to get access to it because they want to make profit. So implemented a project engaging all this reality is not trivial, and I think we are thinking how to do it. It's not an easy solution. So I think, to me, this is a very crucial time, which if we manage, then we can grow. If we don't go anywhere and we'll be overtaken. I mean, yesterday. So, but solving this problem is not easy, and you cannot blame the Commission for this, because I think we have to thank them for providing constant resources at a time where it's very critical to defend this. But we have to be careful, private and public. They don't normally work together. And I think until we don't find clear rules, and I see this within Eurofusion, I am leading a consortium where there are 29 member states, plus 165 affiliated entities. So if you're part of that clan, then you can talk. Otherwise, it's not easy. So there's I would call it protectionism, which is not good. But violating that protectionism, you jeopardize the risk of those who have put a lot of resources investing and bring them in the hands of somebody who can make money out of it. So I think we have to do it, but there is no easy solution out there. So putting public, yesterday somebody said you are there because you want to get access to the public resources, which is probably true. Importance is that they do together with us something which is useful. Maybe somebody else has different opinion, but They're working on it. I know that they're working on
I was
it.
going to move. I think it's not a question to blame anyone, and definitely I will not be the one blaming the Commission who pay my salary every month. So no, definitely not the case.
I will break a little bit the rules here, and I want to highlight something. I think something that Gianfranco mentioned is extremely important, and we all need to remember clear rules. We need to have these clear rules for the industry, for the public sector, and this is not easy at all, to understand how the IP is going to be shared, not shared, who is going to be the owner. Europe is in a crucial moment now. If we are not able to define these clear rules and this governance, that will kill a potential industry that can generate growth in Europe. So to me, this is the key message, clear rules, and this is why I interrupt, because I want people to remember that this is really important.
Thank you. There is no more rules. Please engage in the discussion, and everyone is welcome also to jump if something is urgent and you cannot wait to the last part. I will like first, we will move to the part on governance, because I think we have many actors and all of them, they need the place. But I would like first to ask Benoit, if you could share with us the key components of the new European fusion strategy and how that it's aimed to stimulate industrial innovation and regulatory readiness, how all things will put together. So, Benoit, please.
Thank you. Is it working? Thank you. Thank you, Asuncion, and good morning to all. I hope you're still well awake, because I will have a question to you at the end. So the fusion strategy generally will aim at accelerating the connection of fusion plants to the grid. But once we've said that, there are several axes of work. The first one, the clear one is to take full advantage of our leading position, our leading role in ITER. There is, as Gianfranco said, and as we heard yesterday, a lot to learn there, and all the work that is done by Fusion for Energy has to be, we have to reap the benefit of this work. Then we have to formulate a path to a pilot fusion power plant. And by this, I mean to address the critical technological gaps which still exist. We heard several of them. I will not detail again. And a difficult one, rationalize the initiatives in the EU. Then we have to build a competitive industrial ecosystem and encourage investment through private-public partnership, and I'll come back on this one, and use the tools which we have at our disposal, which is, for example, the European Innovation Council. We have to develop the workforce. There are people here who are better placed than me to discuss this. And we have to prepare a regulatory framework which is well suited to fusion. Again, on this, if possible, I'd like to come back. We work already with several international partners on fusion. I would mainly quote Japan. We have a very strong and close relationship. So this collaboration has to be strengthened further. And finally, we heard yesterday, we have to establish in Europe a fusion governance, and I would say an efficient fusion governance for decision making at EU level. So I heard yesterday some voices saying the EU is not consulting on this strategy. So I would just like you to know that there is currently open what is called a call for evidence, which can be found on the website of the EU on the fusion strategy, and I really much encourage you to provide input on this. We will consider it. It is open until the 1st of July. So this is, and now I come to my question. There has been efforts in other fields to have public-private partnerships. And
those state-aided companies have not been always successful. There was yesterday the mention of batteries, and the example of Northvolt was one of them, where the company went bankrupt, and with it a lot of public money. So how do we make the example of fusion a success? And this would be my question.
Question, maybe you have time to...
It can be a question that is answered later on.
Thank you. I think it's a challenge, because while you are developing your strategies in parallel to many others, and in fact we are competing. Everyone wanted to make an industry competitive. We are sharing for the same technologies and even the same workforce. So how do you think that the different actors and how this strategy could really attract the interest and the people will really react and go on these things?
If I may,
yes, please.
You remember me asking Marco Nassi yesterday that I don't see a strong voice at the moment made by the industry to explain what are their boundary conditions, what they want to invest in. Because the bottom line to have a partnership is very easy. The concept of partner, which is becoming the fundamental, it's the concept of co-funding. Are they prepared to bring money on the table? How much and for what? This is the bottom line, because it boils all around this. And this is something which industry is not normally ready to do it. And I'm not sure even the startup, because the startup now are looking for funding. They are looking for funding by presenting a plan, and they get the funding from government, private investor. So I think here the establishment or a reliable and effective partnership, public, private, start from that prerequisite, with putting money on the table. And to do what? And until we don't deal with this matter, all the discussion for me are totally useless. So I want to get to that answer as early as possible.
Do you want to react?
Yes, I mean, we could define specific actions for all those areas, but there is one I would really like to emphasize, which is the need of standardization and qualification. In 2021, there was an incident at the JT60SA because, to make it short, there was a short circuit in one of the magnets. It's a very interesting story, but to make it short, it took more than 1 year to repair. So now the question to be asked is, okay, in a commercial view, you cannot spend one year to repair. So those components have to be tested, and they have to be tested according to standards. And those standards have to exist, because for many of those systems, they do not exist. If we want to develop value, we have to move from the development of research and development components to really off-the-shelf system components that you can use and assemble. So questions, I mean, here is Luca. So how should magnets be tested? How are quenches to be avoided? Is the pressure equipment directive to be used for the vacuum vessel? Because this simplifies the, what type of standards do we use for remote handling? What type of materials? So all these are questions to be addressed, which will independently create value and then allow the assembly of...
Thank you, Beno. I think this is why we are here. And in fact, the questions will go to you, because what international frameworks or working groups can help to harmonize these standards and avoid duplicated efforts? Because at the end of the day, it seems like we are passing the ball one to the others. Who will be? As in any other projects, we need a clear governance, a clear structure, how we will integrate the different stakeholders. But if we go exactly on the part of this harmonization of standardization, who will be on the lead?
There are already, and everybody knows them, very well-established standards organization. And in 2024, the ISO published standards on fusion installation and confinement of tritium. I'm giving this example to say that there are already initiatives. But as we speak, Euratom, the Commission, has been very supportive of one initiative proposed by the ITER organization to start to develop engineering standards at technical level. The IO Director General, Pietro Varaschi, proposed what he called an international tokamak engineering standard activity, so it's called ITESA. And we believe that this is one of the ways to capture all the lessons learned at ITER and to answer one of the first, when I said we have to reap the benefit of the work at ITER. So this would be one of the possibility. Of course, this is a bit the bottom-up approach, and you have also the question of the legal framework, which is debated in the other session, from a legal one. But I think we should not underestimate the value of developing a standardization framework applicable to all the components we will need in a fusion plant.
Please go ahead.
I will take advantage of that question to promote what we are doing. I fully agree on what you have said both in general, but in particular on the standard part, is something from Clean Air Task Force we were monitoring for 1 year or something. We realize, as you correctly say, if you want to do things in an industrial manner, you need to have standards, because any commercial industry cannot afford to be 1 year solving a problem. You have to have standards to avoid that and to collect lessons learned. So we started an international working group on standards for fusion 3-4 months ago. ITER is part of. So I'm glad to hear that ITER has also this support or commitment or whatever the name it is. And the idea is we are teaming up with IEEE, which is a standard organization, to learn from. The idea is to see what is needed, to collect what is available, which is limited, and to set up priorities and eventually to start to work on that priorities. But regardless of Clean Air Task Force or whoever who does it, standards are needed for fusion if we want to be an industrial sector. Otherwise, we will be in the R&D area forever. So.
But still, I would like to dip a bit more on this, because how we will steer and which mechanisms can be put in place to ensure that all stakeholders are involved at the moment that is needed. I mean, we are mentioning industry. We need industry. We need their private money. But in which moment, because industry is not really calling for us, I think.
And I would like that we give afterwards, if I may suggest, Dario. One of the concerns that I have is not just industry, is to be able to attract the young generation, because we might end up have industry and not the young generation.
We will move very soon.
Because this is, for me, the big risk. And frankly, and I see the problem I have with my kids, to attract the young generation is becoming extremely difficult. And just to make sure, again, this is an area where Europe is far ahead than anybody else. We are not as good as CERN, but good enough. We have indeed put quite a lot of resources so far in training people. And we are trying to use the same facility mentioned to train the people. We have, since Eurofusion has been established, for the order of 1,000 people, we are paying the master of FuseNet, but I think the problem here is that if we want to accelerate, education, it's a weak point. Because frankly, to become a fusion engineer is something you don't learn on Google. You need to be educated in university, and I discussed this with a panel outside. They're not university representative here. They are indeed the rate controlling mechanism, because there are not courses, they're not professors. So I think we should not miss that part. Accelerating fusion implies accelerating education program, establish new education program, which Guido tells me.
We will move to the part on the skills in a minute. I will just wanted to look at us for an intervention and then.
Just two elements. You were asking about how to attract industry, and there was a discussion about industry partnership, public, private, and so on. So, again, I just want to bring maybe a 90 degrees example here. I think key to developing a successful partnership is recognizing roles and expertise in the various parties. Mm-hmm. A practical example, usually we have big contracts for the LAC, the magnets in particular, because I'm familiar with that. You spend months and years to prepare the contract, and you realize at the end that the important thing is that you are there with the industrial partner. Unless you are there, it will not work. Okay, and so we went to an extreme to saying in the preparation for the high luminosity magnets, so these are niobium-13 accelerator magnets, never built before. I did an experiment. I took 3 industrial partners on site. There's a lot of experience on site. We have manufacturing facilities. We can make the magnets, but we don't work like industry. There's a lot to be learned from the way the industry works, and they have a lot of interest to see in the way we work as a scientist. And so for 3-4 years, we worked with the industry, developing tooling, procedures, and the way we build the magnets. Now the magnets are being finished. Okay, so I find that a very successful experience. And I think if you want to build partnerships successful, accelerate, recognize roles, recognize what their experience is, what your experience is, and then build upon that. That makes it stronger. Now, how do you attract the young ones? Because it was the other question you were implying. Essentially, you make them dream, right? That's the point. But they have to dream on a time scale which is applicable to them, okay, not for their nephews and so on. So give them something they will see the result of, and then give them opportunities to grow. Infrastructure we already talked about. Collaboration, I think fusion is very strong on that. I think it's a very good point that people can circulate among labs. And I think as well that training does not simply imply training students, but also training the professors, training the teachers. And that's a program we put in place. We have teacher training, so they come by the hundreds every year, so that they have fun, actually, and they bring it back into the schools.
Thank you very much, Luca. Indeed, this experience on sharing industry research is essential because we do not speak the same language. We don't have the same time frame, so it's a great thing that is done at this experience. And definitely how to keep motivated and engage these young generations when they are really on a different time concept. So if we will say in 20 years you will have something, definitely it's not, but we will need to go step by step. This moved very nicely to the next session on the skills, which I think it has been addressed several times, and there is no education, there is no university. I would like to ask Dario, how we can create accessible pathways from education to meaningful careers in fusion energy, considering that there is not as such a fusion energy career. Please, Dario.
Yeah, thank you very much, Asun. And well, thank you everybody for being here, and Gianfranco for the nice introduction of FuseNet. So perhaps before answering your question, I would like to explain shortly what FuseNet is and does, because I think we have the responsibility of the young generation. So it's good for you to know what FuseNet is. So FuseNet stands for the European Fusion Education Network, and our mission is to coordinate, promote, and support fusion education all around Europe. So we are a non-profit association which consists of around 65 member institutions between universities, research centers, and a few of the industry, but very little, and we hope to change that. But at the same time, we are a Eurofusion affiliated entity. So the funding that we get for our activities comes from Eurofusion and the European Commission. There is in the grant agreement of Eurofusion and the Commission, there is an annex specifically focusing on FuseNet. So that allows us to be at the heart of the European effort towards education, training, and skills. So this is pretty much what FuseNet does, and we target the young generation through very concrete actions. So let's say that I'm proud to say that FuseNet operates at a ground level, discussing and being in touch with the students, with the educators, and with the people who are training the future workforce. And mainly we do through mobility of students, so our core business is promoting student mobility around Europe and sometimes even beyond Europe on Fusion internships and attendance to educational events. And we also organize activities and events to promote Fusion among the young generation. So this is pretty much our core business. And of course, we are integrated with all the efforts that EU is doing now in Fusion. So coming back to the question, I think there's many factors to be involved. I think already some of them mentioned by you. Integration is one of them. I think for having a career path or advancing Fusion education in Europe, we need to have integration between all the members of the ecosystem, meaning universities, research centers, the supply chain, and also startups. We need to discuss and see what is the goals of the educational parts, because you have to take into account that academia brings a lot of academic rigor into the formation, but the skills and the gaps that we need to address are identified by the research centers and the supply chain. So we need to coordinate, because we don't want to have education being too theoretical, because we need to address specific gaps that even Gianfranco and all of you mentioned, but we also need to not to be too specified in some things. Of course, we need to solve key issues, but we also need to have an overview of the Fusion, let's say, relevant topics for the students. And maybe one thing to say is that we also should focus on vocational skills, because usually what we always think is academia paths and academia pathways, which are still necessary, but given the new, let's say, skills required and the new roadblocks that we have to address, we also need to tackle other types of education. The vocational training is really important. Internships, mobility, I think that's the key part, because we want to promote Fusion facilities and training in the Fusion facilities around Europe. We want to bring new facilities, but we need to be able to involve students there and to bring them there. And also for the companies, but maybe we'll discuss a bit later about that. I don't want to extend too much. But maybe for the companies, it is also important that you are integrated into this, not only it needs to be committed. So we need to bring value, because the students are also looking forward to be able to be included in this supply chain. We get a lot of requests from students. How can I get into this new Fusion initiative? How can I get into the supply chain? And we, to be honest, we don't have the answer, because we are not connecting with you at the moment. So we need to connect, because we already are in place. So, yeah.
Why do you think it's not the connection? Who should really initiate the things? Because it's a demand, it's a need.
It is a need, and it is a need. So perhaps, perhaps to say something, so we should connect. So I think that we are a network. Fusion is a network, and one of the main things for us is to connect with you. I have to say something about the educational efforts in Europe. I think on that part, we are one of the leading continents in that. So yesterday we were discussing who's leading what. Maybe the EU is not leading on something. For the educational part, we are leaders. Doesn't mean that we're doing enough. Not at all. But we are leaders. Actually, the model that we're doing now is trying to be extrapolated to the US. I was last year in a conference, a Workforce Accelerator conference in the US, and they invited FuseNet because they wanted to see if it was possible to have this model within the US, because I think they are not doing enough of education as we have done already for so many years. Actually, this year, FuseNet celebrates the 15th year anniversary. So we already have something in place that works, but we need to incorporate the new players, and that means the supply chain. Historically, we have been always working with universities, with formation, with the research centers through Eurofusion, but the supply chain is something a bit of a mystery, because perhaps it was not the time earlier on, but I think now is the time to incorporate the supply chain, and also to know that if you have open positions for students, we were discussing yesterday about return of investment, and the way I see it in the educational field is that you have almost an immediate return of investment, because you get the students to be placed in your companies or your research centers and addressing the topics that you need to work on. So it's almost immediate, and you start training the workforce very early on at this stage that we need it, and we will need it further on. So
I see Gianfranco wanted to react, but I have an immediate question to you, Dario, because we are focusing also a lot on students, which is hyper important, and we need it, and this is our future labor work, imminent. But what about upskilling, reskilling? So this fluctuation, people are also attracting those that they are, well, in an area that they cannot, and we can convert things, or or even how we can attract to the fusion sector colleagues that they are not even, I mean, we are focusing on STEM engineers, but we have seen, to put this in motion, public procurement so how we will attract people, how we will give this small knowledge that you will need to enter in this world to even contribute in other parts. Are also part of FusionNet? Are you also including not only students?
Not really, no. So I think I'm going to be very short on this, and I'll give the word to Gianfranco, because actually the part of upscaling and rescaling is being developed by Eurofusion in connection with us. You should know that FusionNet works really closely with the education and training part of Eurofusion. So Fusion is mainly focusing on talent attraction at the early stages and fusion promotion from the young ages in primary school. Upskilling and reskilling is very important because it is now what we need to do with the current industry that is in place. So I think it's important. There are initiatives on that, but I think it's more on the side of Eurofusion. So I will pass the ball to Gianfranco.
First of all, happy birthday. I think you said one thing which is important. Europe doesn't speak as loud as the Americans, but we have the best education and training program in the world. I brought with me, and you can have a look, 2 brochures that shows the training and education program in Europe and the knowledge management transfer. And for this type of activity, we have a very good collaboration and dialogue with Fusion for Energy. So actually, this is another link we have to strengthen because we are trying to do. Attracting young people is not easy. Actually, I have a very surreal problem that I need to solve. There is a lack of skills in engineering. There has been a sort of much attention on plasma physics up to now, which is okay because, as it was said by somebody else, we are moving, probably Seila, the last one, we are moving from research towards an industrialization. We lack engineers. Engineers are difficult to find, and there is competition for engineers. Now, I managed to find a number of good engineers, which I have to recruit with temporary contract, because in the organization I represent, not having a legal entity, I cannot hire people, so I had to rely on the goodwill of the beneficiary to hire them, temporary contract. Now, they're very good, and they don't have a contract. So I think before we start, and this is what the problem, there are some members of the General Assembly here, and they know that I tell them, look, I think we have to reflect. Either we develop a new generation and we attract them with attractive job opportunity, which they do at CERN. Otherwise, it's pointless. So I think we need to, is industry going to hire these people? Are startups going to hire these people? But then I need to understand, why do we need as a public to develop a training program where then we lose the people? You and I were part of this young generation. We were trained and educated. We were able to spend our time in an organization, which was called a net team then. But even that, at that time, there was not a career-oriented path. Fusion for Energy cannot hire new people. So I need to find a way to find an employer for some of these hundreds of people that we are training and we are not able to retain. If not using very complex location parking lots, is not fair towards them. So please help us to find an employer. Otherwise, these people go away.
Indeed, Gianfranco, especially because you are competing for the same people that other key and critical technologies. So this is the main point. It's not us choosing the workforce, is there, the young generation choosing us. So,
but indeed, the plan is needed, but the governance, to me, is also to find a way to implement a project, offering attractive opportunity of employment for those who are part of this project. And so far, we have saturated organization in Fusion, because I'm not blaming the head of the labs. They are full of physicists which cannot go to work in ITER because ITER is late, so they don't have vacancy. And the government now are strict in open new vacancy. Fusion for Energy doesn't have any post because of you. No, it's difficult to really find easily opportunity for employment. industry, it's an opportunity, but if they are not in, they are going to use these people to do something else.
This is reacting a lot of movement in the college. So Guido and Seila wanted to react on this, so please.
I agree with Gianfranco, but first of all, to come back to attracting young people, I'm rather optimistic on the one hand and pessimistic on the other hand. So the number of young people interested in climate change, energy innovation is growing. But of course, as Asun said, there are other people, other companies who are attracting the same profiles. So we have a lot of competition, but we have to try to attract them. But they have also to have a career perspective, and that's exactly what you said. Now, yesterday the representative of ESA said we cannot compare society in Europe with India, with China, and so on. It is true, but I want to give two examples. In Europe, in higher education, on average in Europe, 30% of the students go in a STEM direction. 30%. In China, 60%. So if you think on the long term, for me this is a bit like a ticking bomb. No? And on the other hand, if you ask the Chinese, so they are developing also education, training, and so on, but they say all the graduates have a guaranteed position in university, in research center, and in industry. So industry is obliged to take them. Of course, this we cannot do in Europe. But if you talk about strong governance, and so it is something to think about. On the other hand, the capacity in Europe to educate and train a growing, hopefully growing number of young people is limited. But maybe one a bit provocative question, Eurofusion, the fusion program is, as far as I know, the most coordinated in the European Union. But why is the education not coordinated, the education in fusion? So we have a number of member states, about 13 to 15 masters, national masters, but there is only, even after 20 years, only one international master, not only in Europe, but in the whole world. It is the Erasmus Mundus Master, which was established in 2006, after we knew that ITER would be built in Europe, after European Commission established the Erasmus Mundus, but still now, there is only one. And this was for us like, I would say, a quantum step. Instead of one university or one country, we have 8 universities. Almost all the large research centers in Europe are involved in this. So the pool of expertise, of supervision is much, much larger than what one university or one country can offer. And of course, there is FuseNet, and I don't want to criticize what Dario said. By the way, Dario is an alumnus of the Erasmus Mundus, so it's a living example. But it is a platform to coordinate all the educational activities. But first of all, there have to be activities before you can coordinate them. And so, as you say, we need a growing number of engineers in the Erasmus Mundus now. Since last year, we established 2 study tracks, one in physics, modeling and so on, the other in fusion technology. So from the beginning, 2 master years, but of course the price you have to pay, well, price, it's an investment, it's not really a cost, is that an international master or European master is substantially more expensive than a national master because of the physical mobility. We organize joint events and so on, but fusion is so international now, there is more and more fierce competition with China, with the US, that also the international aspects are more and more important. And so maybe two side questions that could also be solved or should be solved, I think, by Europe is the faster recognition of qualifications across the border. And secondly, the visa strategy. Because I can tell you from 20 years experience, I have seen a lot of Kafkaesque situations with visa. So students from outside Europe were obliged to leave the master because they didn't get a visa for the next country. So this is really something, yeah, really Kafka. And the last, I would like to give an historical example of very long time ago. After the Second World War, the nuclear engineering development to a discipline in the United States, an academic discipline. This went very fast. And by the way, after Enrico Fermi had his first reactor in Chicago, short time after, there were already research reactors to test the effect of radiation on materials. So he already said in 1946, irradiation of material is crucial for the future of technology. And so this development has been in a very short time. And if you look at similarities, they started also with a more physics-based, physics-oriented program, which evolved to technology, power exhaust, control, irradiation, and so on. So there are quite some similarities, but there was also a strong federal government support, and because of this, it could develop in a short time. Of course, you cannot, not fully compare fusion with fission, but it gives maybe some ideas to think about. No? And a last point, involvement of industry. To be frank, we tried in these 20 years to contact companies. Of course, situation is different now. We have some renaissance and so on. But if we ask them, are you interested to take the student for an internship or maybe scholarship and so on, it was always very, very reluctant. So we had in these 20 years only a very few, I can count on a few fingers, the number of students who were in an internship. And I hope that now they will understand that the situation is different, that we have to change.
I think before that we will enter in a bilateral discussion. I will wanted to hear your views from Sehila and Dario, that they are really looking at me, and then we will wrap up on this.
I will be really brief. I agree that Europe is in the leadership position of training young people. Just two things. The first thing is, if we want to show a career path, we need to include the industry. We need to ask the industry, how many people do you need? Which are the profiles that you need to try to make this career path possible, together with the public sector. And the second thing, I'm being a little bit provocative. If you see at this of what is going on in UK, where they are very focused on technology, they also include in this training technicians. We are also here, we are only here talking about physicists, engineers, which are really needed, and engineers in this more technology approach. I fully agree, but if we want to have profiles which are useful for the industry, we need also to include technicians. It's something we cannot forget. And so far, to my knowledge, in Europe, that has not been contemplated. And this is a reason to put a company here or not if they are able to find the manpower that they need. Physicists, engineers for sure, but also technicians. So.
Thank you. Yes, I think there are many key aspects to discuss, especially with the skills needed and who's going to define these skills. So I second Guido, no criticize for future. I understand. We always say that we are not a higher education institution. We are a coordinated and support entity, and we know it is true that there is a shortage of education, specifically in fusion at the moment, for all the requirements of personnel that we need. But it is important to specify which kind of needs and how do we create these programs if we want to create and bring more opportunities to students. So we attract the students, and students and general public, to be honest, they're really keen on fusion. So fusion has still this attraction, perhaps that we have been in the field for a long time, so we sometimes focus more on the issues and the problems which need to be focused, but sometimes for the young generation especially, we miss that spark. That's still there is a spark for people who are interested to come in the field. So what we need to do is to bring them and to provide them a career path, and that goes through many actions. Could be, for example, the one for education and creating more programs. But I think in this case, we need to involve, we have said many times, industry and the people involved, because I've seen from the European Commission, there is also support for this kind of activities. Erasmus Mundus is a broad scheme, but there is always something from the Commission that says that this needs to be applied, so you cannot have too much theoretical aspects on this kind of education, especially for the moment of fusion that we are now. We need to start addressing key technological showstoppers. We need to bring engineers in the conversation. So the new programs that we want to form, they have to be coordinated already from the start, not only from the universities providing the academic rigor, but also with the research centers and the companies that need specific skills. And it could be not only masters, could be also vocational training. These technicians, welding is a topic that always comes in fusion everywhere. Welding is very important, but of course, I hardly see a master in welding program like so. So we also need to discuss this, but it is a matter of integration, and it's not a matter of people seeing the value, and by people I mean the industry, universities, research centers, startups, seeing the value in getting involved, both commitment and applying resources to this kind of masters and initiatives that already have funding from the Commission. So it's just a matter of making these connections and finding these key elements that can make a master program or any kind of educational program appealable for students, but also for the people who are going to employ these students in the future. So.
You, in your summary, I think I've already discussed this with the private investor, because the private investor could help us in that regard, because I think there is a misunderstanding. They are trying now to take away the resources that are in the public, and they offer them opportunity, but they see there is a limited reservoir. So they are so effective in getting money. I think we should use their ability to interact with the power centers and to make sure that they help us, and together with them we develop new university path, because the university path that Guido was, this is another level. I don't know, all of you have been in the university. You cannot open a path in the university without asking the permission of the Pope. I mean, to exaggerate, but the private investors are far-reaching there. And if there is one thing we have in common, is the opportunity to develop a new, qualified, competent generation. And for that, we need to have new university program, like it was after the nuclear reactor, because nobody's going to open a career track on fusion engineering, except we work with. So please, whenever you say that we believe the private investor can accelerate the formation, the training, the education of new stuff. And I think they will.
Exactly, I could not agree more. I think we need to put together the supply and the demand. If they would not communicate, they could be on divergent things. This is obviously of interest. I see both of them raising hands. So please, Benoit. I thought that you, but look at you.
So just a remark on technicians. I strongly support that remark, because even at CERN, we have a very hard time to find good technicians. So we came to the point, and maybe that's an idea for you if you want to develop it further, to have a special fellowship for technician. So they have 3 years, they enter with their qualification, and then they're trained on the spot, right? So in the skills that we need, actually. So maybe something to consider in industry or laboratories.
And Luca, just as a follow-up, how do you ensure that once that they are trained, they will stay with you? Which is the attracting factor, because it's not only to attract the talent, but it's to retain.
Well, I must say we are blessed by the fact that whoever gets there for a few years wants to stay there, so we have no problem with that. But we don't have enough posts for everybody. At the same time, we tend to build a community of engineers, technicians, physicists that stay within other labs and other industries that are actually interested in them, so that we profit from the education we did.
I would like to pose one question to Guido, because it has been mentioned many much, the university, the academia, but in your view, how do you, in your experience, how do you deal with the growing need for training facilities for students? So, because the academia could really provide on all the academic aspect, but how you make the link with the training facilities?
Yes, what you mentioned 10 minutes ago or so, upskilling, reskilling is important, but the technology hubs we were discussing in the beginning of the roundtable, and the training facilities can also be used for technicians, not only for researchers, for engineers, but for technicians. But to give, again, one example, concrete example, it is not from fission, unfortunately, not from fusion, it's from fission. In Belgium, we have something called BNEN. It is the Belgian Nuclear Energy Network, coordinating the activities of 5 universities in Belgium, but in collaboration with the Belgian Nuclear Research Center in Mol. So they have facilities, and the students from the different universities, but not only from the universities, there are also people sent by industry for upskilling, reskilling, who have an engineering degree in another field. But in 1 year, we call it master after master, in 1 year, they can have a nuclear engineering degree and for training use the facilities of the Nuclear Research Center. So this is a good example, which I think could also be followed by the fusion community. You know?
I think just to follow up, and I will conclude on these things, but something that it has been mentioned by you, issues with visa, how we will attract, I think we have a huge opportunity. I think now the Commission launched the Union of Skills, which is really addressing this part on the upskilling, reskilling, to have micro-credentials, because per se, an engineer, an industrial engineer will not work on this. So what it will be the extra curriculum that they will need to enter on this. So definitely micro-credentials, accreditation things, it will be of use, of interest. I think due to the geopolitical situation, we have also a chance. It's going to be launched a program which is Choose Europe. I hope it will be implemented before all the talented engineers will go elsewhere. But it's a possibility to attract talent to Europe and to complement on these things. And yeah, we have the opportunity, so let's do it. I think, Dario, you wanted to.
Yeah, perhaps something to comment on, because you mentioned the skill and what kind of efforts shall we do from Europe and what Europe is doing. Well, actually, Europe at the moment, yesterday we heard about the private-public partnership CSA, so that's called for skill actions with the companies in fusion. There is at the moment one going in parallel, so it was the same call, a CSA call for nuclear skills. So this and different, it is not focused only on fusion as the previous PPP is, it is a fusion collaboration. And to be honest, it is mainly fission because it covers a lot of parts, and fission is already an established industry. But still, the Commission felt the need that we incorporate fusion there because the development of skills at the European level has to be coordinated. So Fusion is part of the consortium, and there is also the Institute of Plasma Physics in Prague that is a Eurofusion beneficiary. So in a sense, Eurofusion is also involved in there, although not officially. We are officially as Fusion there. So we are collaborating. This is a project that started now, just like the Go for Fusion that was mentioned yesterday by Carlos Hidalgo. So at the moment, this project is starting, but what we want to do is actually to focus on this and to create a strategy for Europe in the terms of nuclear skills, the needs, micro-credentials, or any initiative like this, so it is encompassed. And we are all, of course, open to receive input from the people involved, so from the industry, from academia, again, everybody. So perhaps it's a little bit of promotion on that one, but it's good that you know that there is already an initiative in place that actually needs input from the people who are thinking about skills and who are focusing on skills and bringing projects in fusion. So yeah, just if you're interested to know more, you can connect us and we can work on that.
Thank you very much. I am looking at the time, and my colleague already alerted me. I have one last question for each of you, but first I would like to open the floor to the audience in case that they would like to make any question to our experienced colleagues. You see, I expect it. So please, will you need the microphones? I think it's the lady with the...
Good morning, everyone. I'm Laura, and I'm exactly the person you're talking about. I'm super young. I graduated in 2023, and I graduated in Politecnico di Milano, one of the best universities that Italy has. And it's true. First of all, we should invest more about fusion. I just had one course about plasma physics, and that's it. But the real question I want to propose you is, who is really ready to invest on young people? Because this is the main problem, no? I'm lucky to be here. I did good at university, okay, but who is really ready to invest about nuclear engineers? I had a very big problem about it because most of my colleagues are not working anymore in nuclear because there is a great lack of positions.
That's a very good point. I didn't capture your name. I come from the Polytechnic of Milano.
I'm Laura.
1985, I graduated from the Polytechnic of Milano. And at that time, fusion, there were no courses. So I had to go to the US to become a fusion expert. And there were courses, which have disappeared also from there. I had to rely on the funds of my family, my father, and support from taking an assistantship there. They were very well organized. I had the opportunity to work there. I decided to come back. Now, going back to your question, I think you're asking something which is very important. Who is going to invest in us? I think we need to establish now attractive track courses for you and find a way to make you access in these courses. And remember what I get? I think we know that we need engineers, but we cannot provide you with a very attractive path. You are probably here working for Fusion for Energy in a sort of a temporary contract, and what you do next year. That's the problem we have to solve. Otherwise, you don't come. Otherwise, you don't study nuclear engineering anymore. Except now it's coming back. So it's a good question. I think you have to raise this. I'm trying to go back to the network of university I have access to bring this up. Because with all the due respect, I think nuclear engineering is the closest to a fusion engineering. And in Italy, there are, because of our national inertia, we didn't close them down, and they are still there. And they still produce fantastic talent. But how do we help them? Learning more about fusion and finding a job. I think this has to be emphasized in your talk at the end. Barbara, we can talk to you afterwards.
Yeah, I would like Luca to complement, because I think, Gianfranco, your example of going to USA is not what she was asking. So, Luca, can you offer her a position instead?
Yeah, no problem. So yeah, I was going to, so no problem. So, in fact, I do not have the answer. I think what you see in the panel, and in fact, the name of the session is the fact that there is a need and that there's the wish, okay? I know it's easy to say, and unless you have a contract signed, you're not happy, and you're right, okay? So there I support what Gianfranco just said. There should be a system that allows this to happen. But just to tell you, I'm a nuclear engineer. I graduated 2 weeks before Chernobyl blew up, okay? Then I moved field, because Italy decided nuclear energy was over. But it wasn't for that, actually. I moved because my future wife would be there. And I moved into superconducting magnets. I started working for the ITER magnets, niobium-13, niobium-titanium, or LTS, the year that they found the HTS materials. Okay, so I'm a disaster. Nonetheless, I was extremely satisfied by the ability and the skills that I learned and the ability to apply them and have something realized. And I think for me, I repeat it, it remains a key. You want something realized of what you learned in university. And so I think the urge is not just having careers, but it's careers that take you somewhere. I think that's an important challenge for those on the panels, us as well, obviously. CERN has the same problem. With the timeline of projects that dilates to the 20, 30, 40 years in the future, people no longer want to do high energy physics. And it becomes a challenge for us as well.
Thank you. It was two other questions. We will take, I think you were first, and we will have time for all questions.
Rich Kembleton from Gas Fusion. I think one of the issues has been raised is the shortage of new projects coming online to grow the workforce and the demand for these people who are being trained. And on that point, I wanted to come back to Gianfranco's point earlier about the shortage of fusion neutrons and projects like VNS and others which are required for testing and developing technologies. These facilities are too expensive for any one company to build itself. Is there a role for F4E and Eurofusion in defining these to some extent as user facilities where companies can come in and use them to develop and qualify their own technologies? And is there space for that in the market as well?
I'm sorry, I mean, I understand that you are wishing that this technology are developed by public, but because I think it could be a potential investment also for public investors, okay? So I see, well, if there is a recognition, and we are not there yet, then this is indeed needed. I think we must be able to realign the attention of some of the startup towards this priority. So in a sense, I understand that all of you is trying to look at commercialization. I tell you, if you know everything in blanket, there is no commercialization. So I think while I let you go towards commercialization, and we need to get money from the public for doing the initial step, I think here there are opportunities which we need to discuss together. But it goes back to the question, how can we have a table where we can sit together and develop, identify a project where we can work together? Because I think, Richard, you know better than me, it is going to be very dangerous if we don't realign our priorities. In that, not on everything, but on something, I think we have to exploit the possibility to have common investment on something. And I believe, going back to what you said, if there is an agreement for the public to define a new project, a new plan, I hope that the private investors are there and the startup are there. Not all of them, but some that should be there.
The project is needed to really attract money, people, and please. It was two other more questions.
Hello, I'm Sally Forbes from the United Kingdom Atomic Energy Authority, and I work a lot with regulatory development and international regulation. So I think you hoped regulation would be brought up at some stage. The focus on skills and training has rightly been on the young generation for the future. But if we look at regulatory frameworks and government policy, we need to reskill and upskill a lot of people in that area. Many will have a background in fission or particle accelerators. So I just wondered what experience or what ideas you have for upskilling and reskilling some of the other generations that will now come into fusion. Thank you.
I have an idea. This is something that it is needed everywhere. I mean, starting from US, UK, and now in Europe. The first thing that, and I was tempted to include it in the gaps, but I thought maybe it's not exactly the session, is, and it was mentioned yesterday a number of times, a regulatory framework in Europe. And honestly, and this is my personal view, we need to avoid fragmentation. Regulation is something in sovereignty of each country of Europe, but the European Commission needs to make an effort to try to find sort of harmonization guidelines that all countries, all member states in Europe are compatible. And this is a hard job. Said that, I think this recycle of professionals coming from nuclear, from aerospace, from other areas into fusion is needed. There is a lot of knowledge in safety and regulation in these areas, but it's not one-to-one to fusion, and this needs to be recognized. And the only way that I can think about is to have sort of master courses, whatever academies to enable this recycle. It's a really important point because it's needed. And new startups will need, public new projects will need this knowledge in safety and regulation. Just a quick promotion of our training course that we are doing in CATF, and we, at the end of at the end of June, this is the idea, to show regulation and safety to people, and the idea is to have sort of equivalent 3 days in Europe at some point at the end of the year. But
Yeah, so maybe I mentioned earlier that we don't, as Fusion, we don't do much about upscaling and rescaling at the moment, but we are involved in an initiative that is actually also starting from the Eurofusion side, from the education and training, and that it's a special type of training, for example, starting with operators training and specific short trainings where actually you get all the expertise from the on the needs for specific sectors within the fusion, because you can, of course, you cannot start with everything. You should start very, very basic and concentrating on specific needs, urgent needs. So I think upscaling and rescaling comes through, like you mentioned, this special, could be a master course, but I think in specific fields of fusion, very technical ones, what you need is technical training already offered by the people who are working on the field, and sometimes integrating people who were working on the field, because there is also initiatives for knowledge management and knowledge transfer, because also that's really important in fusion. Seeing the timelines that we are working on, it's important to have all this knowledge transfer to the new people, to the people that we bring from the other sectors as well, and to have it already kind of in a, let's call it storage, or have it available from the previous generation who are already working in fusion. So I think, yeah, that's an effort that we should be undertaking, yeah.
Useful, and we have to. Yes. Is one question from the audience, and then we will pass to the Slido, that I know that there are several questions there.
Yes, hello. I work in an institution, in a think tank that is only specializing in artificial intelligence. And we've been looking at the nuclear industry, nuclear, both fission and fusion, for about a little less than a year now. And I was very excited by Sehila's at least mentioning of AI, because I've been going to a lot of fusion events, fission also, nuclear in general, and my personal impression is that this is one of the scientific/engineering fields in which AI is less used, penetrated, and understood. I mean, and I would like to have your opinion, the whole panel about it, because I was surprised, we were surprised by seeing how little, be it in fusion research, be it using AI tools for licensing in fission, how little AI is not only used, but even understood. I heard professors saying, now we've been using AI for the last 20 years. Now we do the calculations with computers instead of doing it by hands. I'm talking about nuclear professors. Now, someone who says something like this has no understanding of the thing that artificial intelligence is innovation by definition. I mean, what is available today as methodology was not existing a year ago, not 20 years ago. So I would like to understand what is in your different roles and positions, what is your take on what AI is, and how, if needed and if you believe it necessary, it can be brought into the industry? Because I heard words like acceleration, innovation, Silicon Valley style investments. You can sum up that under the word artificial intelligence. And by the way, you want to attract new talents. You want to have teaching methods with them that can attract them and get them enthusiastic without promising them something that will happen in 50 years. Same thing, the word is artificial intelligence. I'd like to have, at least that's what we believe, so I'd like to have your take on that.
Thank you, very relevant question. And
I'm not an expert, but I can provide you with a few ideas. One of the big challenge, for example, at ITER is the question of the data management, configuration management, and generally speaking, project or ensuring that you have a very recently, AI tools have started to be used on this, and you have access to data in a far easier way as before. I think this is only the beginning, as you mentioned, and there's a high potential of use of those tools. Now, I'm afraid if you ask the question how to license ITER to an AI, it may not yet be ready to answer.
Maybe we can pass to...
unfortunately, we cannot take all the questions in the room and online. Thank you for those who have participated on Slido. You can see everything that's been put in there through the code. I'd like to ask a question based on a keyword I've seen in a few of the questions, which is diversity. There's a question on how can Fusion empower the diversity of profiles that there are from contract management, project experts, cost experts, and also diversity can be linked to the gender balance that maybe is not there in Fusion and in engineering. How do the speakers think we can tackle these gaps?
If I may, I'm the chair of the Women in Fusion group, which is something good but far to be enough, or far to be able to do all things that are needed to be done in terms of diversity, and I'm talking about gender balance. In Fusion, the situation is not great. We are worse than Fission, depending on the country, so that means 20% or below. Said that, I think we have an opportunity now. There are new approaches to Fusion, not only new profiles, but more people are interested about this climate change and the need to take action, and Fusion could be a really good path for that. With all the complexity of the situation, and you need to go case by case, and I will say age by age, because it's not the same attract to a person when you are in high school, at the university later on, to retain the person in the field and provide a career path, because at the end of the day, everyone needs to have a career path to stay in a sector, otherwise you move somewhere else. So, but I think what Fusion needs to do is to promote themselves, to promote at the high school level, to promote at the university level, so students, young people will see an option for them, and that needs to be complemented with a career path. Okay, you have an option you like, you enjoy, you want to help the mankind to get better, to have a clean energy, to a firm source of energy, okay, but you want to have also this career path. And in terms of gender, I like a lot to promote showcases. So you see that women can be in Fusion. You see that the women can deliver pieces of components to ITER. You see that women can be in a management meeting and take decisions. So showing that examples is very important. In Fusion, we have still a way to follow. That needs to be included in the plan. So the problem is that should not be forgotten. It should be a conscious action every time we do something, every time we promote Fusion, every time we have a meeting, we are sure we have the right picture for the right audience. And step by step, it needs to be built. Said that, and this is a very superficial answer, that needs to be integrated in the plans. And I'm looking to Bernard in the Commission, because that should be written. It's not something that randomly should be done by the people in Fusion. It's something that should be embedded in the program. And diversity of profiles, yes, I'm very supportive of that, because talking to Fusion to business people, lawyers, and so they get interested, but they need to know. And they need to know that in Fusion, we will need lawyers, we will need business people, we need marketing. And it's our responsibility, okay, from the Fusion community to show them that there is room and need for that profile. So,
thank you. I think Guido wanted to react. And
remark concerning gender balance. So in the European Master, since many years, we try to increase it, and we are presently at 30% women, which is still modest, but it is bad. If you look at the European average in STEM, it is 20%, so it is already in the good direction. But in the selection, if we have two equivalent qualifications, we will give an extra point to the female candidate. It's maybe some form of discrimination, but okay, positive discrimination.
Thank you very much.
There was a question down there.
Very, very, very urgent. It seems like a question that has to be done, and please go on.
Question from young people in the room.
Well, so I'm Igor, and I'm currently an undergraduate student. And so I want to tailor the question to Luca. And given your given that you're a nuclear engineer, what solution would you propose to those of us who may be looking forward to a career in fusion energy? Because we have seen that there's a clear bottleneck between how many people want to pursue a career in fashion and the current offer in education. So what would you propose as for those of us who may be willing to pursue a career in fashion?
I must say I have a hard time to hear what you're saying. I mean, these loudspeakers, maybe, Asuncion, you heard?
I was hoping that you were
Yeah.
Maybe if you move here, it was difficult for us to hear you.
Oh.
An advice.
My advice, if somebody wants to start a career in fusion, to me, who moved away from fusion, is that why you're asking me?
No.
That's a good one. Okay, it's a good one, but it's a tough one. So I just start saying, I keep saying the same things all over. I think the important thing is, honestly, I would look for something that gets done. And that means develop skills for something that actually brings you a result for you. Meaning if you're an engineer, an engineering realization, if you're a plasma physicist, an equilibrium solution for whatever you're looking for, if you're looking into AI, whatever new control algorithms you can devise, but within what you think is your useful appointment for that moment. Okay? So 5 years, 10 years, I think you need to get something out of it. I wouldn't, nowadays, I wouldn't wait too long. You know, things are moving fast, and I think it's a good opportunity to also be able to profit, you know, an investment that comes back to you so that you can use it directly. That's what I would do today.
Thank you.
Thank you. Maybe I can complement on this. I will say go for it, because it's an area in which you can decide it where you want it. You can be in the design, you can be a researcher, but you can be in the implementing phase. You can move to the industry. You can be in the majors. So it's open the whole entire life. So it's something that you decided, and it's the long pathway to move in. So obviously, it's something that is not, I'm going to be the next 35 years of my career doing the same thing. You can do it, because we see the colleagues that they have been in the field for many years and becoming experts and gurus in the area, but it also gives you the opportunity to be moving, and something which is also very nice is to see that your own research is being implemented. So for me, it's something that is great, things that you spend the 10 years that he was saying, 5, 10, and immediately you will be in a company. So I think...
I realize I didn't give you the answer. Do something that you feel passionate about.
Yes.
Okay?
So with this, I wanted to... We have to close. I think coffee is waiting for us. I really thank you, the panelists. Thank you for being here, for sharing your expertise, your insights. I know that there are many questions still on, so probably you will be contacted now during the coffee break. Thank you for the organizers. I think it has been very nice to take these points, especially on the skills, that many times is the elephant in the room, but without workforce we will have nothing. So thank you, and it was very nice to see so many young, I'm sure, interested people and talented to join the thing. So thank you to everyone. Back to you.
Thank you.
I just wanted to thank Asuncion for the good chair, the good moderating.